So are we alone? Those three simple words, when you put them together in that order, forms perhaps the most compelling unanswered question facing humanity today. I wish I could say at the end of this 15 minutes that you'll walk away with a positive answer to that question, but I'd be lying if I told you that. Instead, what I hope at least that you walk away with is an appreciation for why the answer to this question may not be the positive, uplifting answer that I think most of us in the room would hope it to be. Now, before I get into the topic, just a bit of geography, a bit of homework. If you were an omnipotent being and you could remove yourself from the Milky Way galaxy in which we live and float above it and look down, this is what you would see. Spanning roughly 100,000 light years across, there's 100 billion stars in that picture. These 100 billion stars are rotating around in circular orbits around the galactic center, each one moving at around 500,000 miles per hour. Amongst these 100 billion stars, there's maybe 1 billion, 10 billion or so rocky planets, the sort of the sites that we might hope that complex intelligent life might evolve upon. Our sun sits in a rather nondescript suburb of the Milky Way, sort of halfway between the edge of the disk and the center of the galaxy. We do sit on a tiny little spur that's in between two very dense, bright spiral arms, as you can see here. And I want you to just sort of take a mental snapshot of this, because we're going to come back and see these spiral arms repeatedly throughout the rest of the presentation. They're going to come back to haunt us when I talk about the development of complex life. But the nice thing to take from that is we sit in a very underdense, sedate, quiet region of the Milky Way right now. If you step outside the city, this picture perhaps doesn't do it justice, and you're in a dark site and you look up into the night sky, you can see thousands upon thousands of stars with the naked eye. And if you're in a particularly dark site, you may see the Milky Way cutting across the sky just like this. And there's a reason why philosophers, scientists, general public, you, I, when we look up at things like this, we want to believe that there is complex life out there. There's intelligent life out there. The sheer vastness of space, the sheer number of stars makes you want to believe we can't be this unique, intelligent entity sitting all by ourselves. Now, and that belief has underpinned the development of all kinds of genres of literature and television and film. And in fact, if you go into, say, IMDb and you take a look at what are the top 20 grossing films of all time, more than half of them are based around this premise that aliens exist out there. And the top grossing film each of the last 7 years has been a film that involves the belief that aliens exist out there somewhere. So we really do want to believe. And if you want further evidence of that, if you're sitting out with your phone, you can go to TED.com and do a search for how many TED Talks there have been in the topic of that are aimed at answering this question of whether we're alone. And this can be related to, the search for extrasolar planets, can be related to the search for extraterrestrial intelligence. There's about 24 of them that I found on the database, which is a remarkable number. There's a common thread that links all of these talks, and that is they're very inspirational, they're very optimistic, they're very uplifting. And so in some ways it would have been very easy for me to stand here and deliver that same sort of uplifting message that we're not alone. But I decided I'd be a little bit contrary and maybe approach this in a slightly more pragmatic, maybe somber way, and talk a little bit about the galactic scale catastrophic events that surround us on our path around the Milky Way, and the sorts of things that at any given moment could wipe us out. And something that not only that we have to face, but any other alien life that may be trying to develop anywhere else in the Milky Way has to face as well. Some of these things most of these things are unavoidable, they're inescapable, they do happen, and they will happen to us in the future. And it's just a matter of when this actually happens. Okay, so where am I going to start? This may not be where you thought a talk on the alien life, the evidence for alien life might have started, but there is a method to my madness, so just cut me some slack for a minute. If you finish searching the TED database and you also then do a search for, say, the most complex, difficult recipes out on the internet, there's a number of things start to show up that you might recognize here. Souffle, baked Alaska, macarons. These things are very complex, they're very difficult. But if you then take a look at what are the basic ingredients, they're very simple, they're very trivial, they're very commonplace ingredients. You mix these things together, and hopefully you come up with these sorts of things that I just showed you. But if anyone in the room has actually tried doing some of these things, you realize these things are very, very finicky. And it does require sort of a deft touch, which hence the allusion to Jamie Oliver, to actually bring these things together and have them come together create successfully. And it requires you to actually have an understanding of some basic science that you may or may not be aware of. When you're, say, with a baked Alaska, you need to be aware of temperature gradients inside of your oven. If you're doing, say, a souffle, you have to worry about protein molecule contamination from egg yolk. You have to worry about pressure gradients in the oven. If you're doing macarons, you need to worry about the subtle effects of humidity and your ability to make these things. These are things you may not be aware of, but they're all come together to demonstrate that it's not a trivial task to take simple ingredients and come up with some complex creation. And that's the message I want you to take from the first few minutes of this presentation. Now, you may think that we already have found life on Mars. If you're a Daily Mail reader, you can find lots of fascinating stories about this. We have a number of rovers that are walking their way across the surface of Mars, and they found all kinds of fascinating, interesting, jaw-dropping things. There's an enormous database of things that you can go and find on the web. It looks like there's evidence for iguanas on the surface. There's a woman sitting on a ridge contemplating things. There's a floating spoon in the bottom left. We've got a bowler hat in the bottom right. There's any number of these sorts of things. Now, it'd be interesting to believe that this is evidence of extraterrestrial life, but the reality is these are just really fascinating rock formations. There's many, 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 many more of them out there. There's an entire gallery on the web, which I would encourage you to go through. It is actually really fascinating. What are the sort of ingredients that we need to think about in terms of life? There are 3 building blocks. There's the ingredients that come together. There is also the oven in which you do the cooking. And there's the amount of time that you do the cooking for. So I'm going to come back and address each of those one by one. But in relation to where we sit on this Milky Way galaxy plot, I want to come back to that point that I said at the beginning, that we sit in a very nice, quiet, underdense region. We're surrounded by these dense spiral arms. What's also unique about this area is we move at around 500,000 miles an hour around the galaxy. At the same time, the spiral arms are winding at roughly 500,000 miles an hour. So we don't run into anything for a large chunk of time. We just happily move in this underdense region. But we don't move at exactly the same speed of the spiral arms. What that means is that every 100 million years or so, we run into one of these spiral arms. When we run into one of these spiral arms, it gives us what we call a gravitational shock. You get slapped a little bit. This lasts for about a million years or so. This is not a good thing, and I'll show you why in just a second. At the same time that we're getting this gravitational shock from the spiral arms, because the spiral arms is a few times denser than the region in between, so we get this little shock. At the same time as we're getting this shock, the sun, all the stars in the galaxy are going around and they're bobbing up and down at the same time. Every 30 million years or so, we pass through the middle of the plane of the Milky Way galaxy. We also get another gravitational shock because it's denser in the middle of the plane than it is above the plane. So we're constantly being buffeted, both from up and down and from our side-to-side motions as we move around the galaxy. And so why are these sorts of gravitational shocks important? Well, I'm going to use another analogy, if you'll indulge me. So if you picture an aerial swing at a theme park in nice, calm conditions, you see the swing going around a pillar. It's very symmetric. And that's great, very stable, very symmetric. If you start to get little gusts of wind, then that symmetry starts to break down. And if those gusts of wind are strong enough, then you get something that's more disastrous. You can get the collision of the actual cars, of the swings. This is exactly the same sort of thing that happens for our solar system as we get these gravitational shocks as we pass through spiral arms and through the midplane of the galaxy. It's not swings that we're talking about, but instead we're talking about comets. Our solar system, we think of it as these 8 planets that are going around the sun, but in reality there is millions, billions, perhaps trillions of comets in the outer part of the solar system that are happily just orbiting around, surrounding us, sort of a cocoon around our solar system. They're fragilely balanced there. Every once in a while, one gets dislodged and works its way down into the inner solar system. Most of the comets that you see pictures of originated out there in the Oort cloud. The problem is when you get one of these gravitational shocks, it can dislodge more than just one randomly and can actually lead to thousands, maybe millions of these comets that come funneling down into the inner part of the solar system. And some fraction of those have the ability to collide with the Earth and lead to cataclysmic extinctions. At least over the last billion years of the Earth, we think this has happened probably about 5 times where we've had mass extinctions over this last 5 billion years. This has happened to us. It's unavoidable. It's inescapable. There's nothing you can do about it. Every tens of millions of years, we are going to get a gravitational shock, and eventually one of these is going to lead to a cataclysmic infall of comets that is going to do the sort of damage that you see in a picture like this. May not be tomorrow, may not be next year, maybe millions of years from now, but it is coming. Now, stepping back again to outside of the Milky Way and looking down on it from above, I'm going to come back to these spiral arms one more time. The spiral arms, you can see in that picture, are brighter. And that's because that's where most of the stars in the galaxy are being formed. Where most of the stars are being formed, that's also where most of the stars are dying. Now, when most stars die, they explode in a very spectacular fashion called a supernova. A supernova gives off on the order of a billion times the energy of the most powerful nuclear weapon that's ever been released on Earth. We have roughly, in our galaxy, maybe one goes off every 10 years or so. Now, the galaxy is really, really big, so if one explodes on the other side of the galaxy, it doesn't have any effect on us because it's really far away. But you can start to ask the question, how close would one of these supernovae have to be before it would actually do some serious damage to the Earth? And we've worked through the numbers. We know what that answer is. It's roughly about 30 light years or so. So 30 light years, that number by itself may not seem like anything, but there's roughly about 100 stars within 30 light years of where we sit today. So if one of those stars exploded within that lethal radius, if you like, of 30 light years, the amount of energy that we would see on the Earth would be the equivalent of about 100,000 of the most powerful nuclear weapons ever released, 10 times greater than you would need to completely decimate the Earth. So you can ask the question, how often, statistically, would one of these supernovae explode within that distance of the Earth? And the answer is, again, roughly around once every 100 million years or so. And once again, this is something that happens. We know it happens. It's unavoidable. It will happen. We know it happens actually pretty regularly. In fact, if you go back less than 10 million years ago, a supernova exploded that was 100 light years away. So 30 light years away is the lethal radius, where you just wipe out the biosphere, you'd evaporate the atmosphere, you'd wipe out everything on Earth. So one went off only a factor of 3 further away, 100 light years. So to put that into context, this is a supernova that exploded about 1,000 years ago. The distance across that bubble is about 60 light years. And I stuck the Earth up in the corner there, 100 light years away. This was roughly what happened 10 million years ago. We know what happened. We can see radioactive isotopes in the bottom of the ocean that clearly came from the signature of an exploding supernova on that sort of time scale. If that had exploded just a factor of 3 closer, so near the edge of that bubble rather than where the Earth actually is, that would have wiped out life sort of 8 or 9 million years ago. So again, it's just further evidence that this does happen. It's unavoidable. It's going to happen. And again, it may not be tomorrow, it may not be next year, but it is coming, and it's coming on that sort of time scale of millions of years. Now that's sort of a fairly grim way to sort of wrap up a talk. So if I wanted to put a positive spin, a slightly positive spin on it, I would end with this point. If we are going to be successful in finding extraterrestrial life, in my lifetime, in your lifetime, I don't think it's going to be looking at distant stars. It's something we should be pushing for. It's something we should aspire to, and we shouldn't avoid the challenge of trying to find out if there's a life out there. My personal belief, I become more and more pragmatic as time goes by, and I start to think that maybe there isn't someone out there. That said, if I do want to find evidence for extraterrestrial life, if it's going to happen, I do think it will happen on our lifetime, but it's going to happen much closer to home. It's not going to be Mars. It's not going to be Venus. It's going to be the icy moons of Jupiter and Saturn, so Europa and Enceladus. These moons are fantastic. They're covered in ice, but beneath that ice is a massive ocean of seawater, very salty seawater. Every once in a while, the planets of Jupiter and Saturn torque and mess up these planets and cause the surface ice to fracture. And then you get these enormous geysers of salt water that come spewing out from underneath the icy surface. We can see this on both of these moons. There are missions that are planned to be launched in the next 5 years from NASA and the European Space Agency that are going to fly through and around these geysers of salt water, hoping to find evidence of simple microbial life. I think there's a reasonable chance that that's where if we're going to find it, that's where we're going to find it. If we don't find it there, then you can start to get really worried that maybe it isn't out there at all, because this is the ideal environment for simple microbial life to develop. So I guess the final summary, it may be a little bit grim, it may be a little bit somber, but I just want you to be aware that there are these galactic scale cataclysmic events that occur on millions of years time scales. There's nothing we can do to avoid them. They're out there. They're going to happen. It's going to hit us eventually. Not in our lifetime probably, but it's coming eventually. And this is something we have to face. It's something that every alien civilization would have to face in the future as well. But even though the pragmatic part of me thinks that maybe life isn't out there at all, I still can't help it. I'm a romantic at heart. Part of me still wants to believe. Thank you.